Good morning, students. In earlier class, we discussed about the basic characteristics of DC separately excited drive and DC series motor drive, because these two drives are helpful for understanding the unit number 1, 2, and 3 in the first part of DC drives in power semiconductor drives. So now in today's class, we are going to be discuss about the next topic. So that is the classification of electric drives. Yes. So based upon the work it does, the electrical drives are classified into different configurations and different models. So let us have a look on what are the different classification of electric drives. Yes. So electric drives generally classified into three groups based upon their development. So let us have what are the classifications here. Group electric drives, individual electric drives, and multi-motor electric drives. So these are the three classifications in which the electric drives have to be classified. So the name itself, group electric drive, individual electric drive, multi-motor electric drive. The name itself, it indicates the functionality of the particular drive. So let us discuss one by one here. So in this regards, the first one is the electric drives. Sorry, group electric drives. So what is the group electric drive? For example, so you see the rice mill. I think most of the people are visited into the rice mill. So rice mill having a large motor, that motor is rotating a common shaft. So that shaft is connected with a number of multi-stepped pulleys. So that pulleys are belted through different motors for various functions. For example, one motor is to be separating the half rice and full rice. Another motor is for separating stones and rice. And another motor is for polishing the rice. Like that, different motors are a group of motors and are functioning with different speeds under one mechanism. So that is the reason the drives are known as the group drives. So let us see here. If several groups of mechanisms or machines are organized on one shaft and driven by one motor. Yes. So if several groups of mechanisms or machines are organized on one shaft and driven by one motor, the system is called group drive or shaft drive. So only one motor that run the big shaft. That shaft is connected with the multi-stepped pulleys, and with the multi-stepped pulleys, the belts are running the various mechanisms. So the various mechanisms connected may be different speeds. As the length of the belt is different from one to other, obviously the speeds also changing. Hence, the shaft is equipped with multi-stepped pulleys. Yes, so multi-stepped pulleys and belts for connection into individual loads. So the individual loads performs the various functions here. Yes, and the rating of a single machine is smaller than the sum of the total loads used, because all loads may not appear on the same time. So this makes the drive more economical. It's obviously true, because all the motors rating is less than the main motor. All the motors rating is higher than the main motor. Otherwise, the rating of the main motor is smaller compared to the sum of all the motors which are functioning for various applications. Yes. So that is the reason this point is initiated. The rating of the single machine is smaller than the sum of the total loads used, because all loads do not appear on the same times. This makes the drive more economical. So this is about the group drive. The best example is the rice mill. Rice mill is the best example for group electric drive. And similarly, this method is see here. This method is rarely used in modern drive system because this system having more number of drawbacks. So when the energy transformation is to be transferred through the multi-step pulleys and belts, here the efficiency is very less. So huge amount of the energy is wasted through the multi-step pulleys and belts. So that's why this method is very oftenly used. Yes. So what are the drawbacks of this method in the sense the efficiency of the drive is low? No doubt in this. When the mechanical belts and multi-step pulleys are involving, the efficiency is obviously less because of losses occurring in the several transmissions. Yes. So the complete drive system requires shutdown of the motor, requires servicing or repair. So one main motor, and according to that main motors, all other motors or individual motors are functioning in that. So is there any trouble in the main motor resulting the complete shutdown of the motor, resulting servicing and repair is required? This is also another drawback because everything is to be depend upon the main motor. Yes. And similarly, the system is not very safe to operate. So this is very common. We are regularly seeing in the newspapers. So the operating personnel, the operating person in the mills. So due to unfortunately any belt is to be repaired, so the operating person has to be try to modify that belt. So during that, there may be hazards are to be happen. So that's why this system is not safe to operate. Yes. And similarly, the noise level at the workplace is very high. So this is also very big drawback. And similarly, the location of the mechanical equipment being driven depends on the shop. So it's not located very fairly. This may be some dark places, otherwise some backside of some machines. So this may be complicate the operating personnel safety. Yes. So that is the reason the location of the mechanical equipment being driven depends upon the shaft. Okay. So due to these drawbacks, the group drives are nowadays not properly, very rarely used, very rarely used. And similarly, the next one, individual drives. So individual drive, by the name itself, it has a individual, a single. So one drive system, individual drive is one drive system performs different functions. So that is nothing but the individual drive. So you see here, if a single motor is used to driven a given mechanism, if a single motor is used to driven a given mechanism, and it does all the jobs connected with this load, is called an individual drive. Yes, if a single motor is used to driven a given load, given mechanism, and it does all the jobs connected with this load, is called individual drive. So that means that I will give a best example is lathe machine. So lathe machine, the machine is one, but it performs the different functionalities like cutting, threading, knurling, growing. Yes. So different type of operations are performed with the same motor, so that it does a multiple jobs. That is the reason this is known as a individual drive. So for example, all the operations connected with operating a lathe may be performed by a single machine. Yes, all the operations connected with operating a lathe machine. Lathe machine may be performed by a single machine. So what are the operations this can perform? Threading. Threading is very familiar. Knurling. Knurling means while observing steel rods, there may be some design on the steel rods. That is nothing but knurling. Turning, that means rotation. Is growing. Growing is also a process of closing the holes on the steel rods. So all these all these functions are performed by a single machine. So that is the reason it is known as a individual drive. Yes. And another one is multi-motor drives. Yes. So the name itself, multi-motors. The drive can having a number of motors. That is the reason this is a multi-motor drive. Yes. So let us see here. Each operation of the mechanism is taken care by a separate motor. Each operation of the mechanism is taken care by a separate motor. The system contains several individual drives, each of which is used to operate its own mechanism. For example, a traveling crane you are taking. So a traveling crane having a different motors and for different functionalities. For example, traveling from one place to another place, one motor or engine is used, and whereas during the lifting point of view, another motor is used. So in some other purpose, some other motors are there. So like that. So the drive consisting of a single drive consisting of a number of motors, and each motor serve its own mechanism. Yes. So that is the reason this is known as a multi-motor drives. Yes. So this type of drive finds applications in complicated machine tools, traveling cranes, as I given the example, traveling cranes, rolling mills. So in all these kind of application, the multi-motor drives are perform its functions. Yes. So it is the classification of drives is over. Okay. Next, we can go for the another topic, which is the dynamic control of a drive system. So this is also very basic of the electrical drives. So dynamic control of a drive system. Dynamic control in the sense, so a drive is connected to an active load when the drive accelerates, when the drive deaccelerates. So based upon what parameters this analysis is to be, as this control is to be analyzed. So this is to be performed. This is to be performed and explained with the help of the dynamic control of a drive system. You see here, especially in drive system, dynamics in the sense, starting up the motor, stopping up, that means breaking up the motor, and speed reversal of the motor. Starting. So we are observing during the starting of the motor, there is a oscillations or fluctuations in the lights or supply voltage. As during these motors switched up also, there may be a brightness in the lights because of there is a voltage fluctuation. Yes. So dynamic or transient conditions occur in electric systems when operating point changes from one steady state to another. So the input parameters are constant, the drive operating at a constant speed. When the input operating parameters are changing due to the dynamic or transient arises in the system, so that it can change the state from one steady state to another steady state. So these variables may be mechanical, such as speed and torque, or electrical, such as voltage and current. Yes. So in mechanical side, we are termed as a speed and torque. In electrical side, we are termed as a voltage and current. And see, what are the dynamic? What are the dynamic conditions? Yes, or when the dynamics or transients arises in particular in case of drives. So these conditions are generally arises or exists during the starting of the motor, breaking of the motor, and speed reversal cases. So for braking purpose, what you have to do, motor operation is to be changed into generator operation. So that is nothing but the speed reversal. Yes. So in all these conditions, starting of the motor, stopping of the motor, starting of the motor, breaking of the motor, and speed reversal, all these are generally known as the dynamic or transient conditions, particularly in case of electric drives. Yes. So what are the causes? What are the causes for these systems? What are the causes for these dynamics or transient arises in the electrical drive system, particularly the energy storing elements in the drive system, such as a mechanical inertia, that is the mass, mechanical inertia J, and the electrical inductance L. These are the responsible for delay in response, resulting disturbance and for variation in the transient behavior. So generally, starting, braking, and speed reversal are known as the dynamic or transient conditions. And these conditions are arises in the circuit because of the energy storage elements in the drive system, such as the mechanical inertia J, mechanical inertia J, and the electrical inductance L. These are the responsible for delay in response, resulting the disturbances and also the variation of the transient behavior. Yes. So a typical equivalent system as shown. So here, simply a motor shaft it is. Motor is having a moment of motor Jm is the motor moment of inertia, omega m is the motor speed. Yes. So this is the shaft of the motor. This is coupled to an external load which is having a moment of inertia of J dash and speed. Speed will be same. Why? Because the both are mechanically coupled to each other. Whatever may be the motor speed, the load speed is also same along with the motor speed. Yes. So it is a mechanical system driven by an electric motor equivalent system. Yes. So one mechanical external load is driven by an electric motor. Electric motor equivalent representation is this. Yes. So the typical equivalent system as shown, the dynamics of the drive can be summarized using the torque balance equation. See here, this is the equivalent circuit. A mechanical load is to be driven by an electric motor equivalent circuit diagram. And it is the dynamics, the dynamic behavior of the drive can be expressed with the help of the torque balance equation. So let us see here. So what is the torque balance equation? So TD is the torque developed by the motor, but J d omega by dt plus b omega plus TL dash. So J d omega by dt is the dynamic torque of a mechanical system, and b omega is the friction torque of a mechanical system, and TL dash is the original load torque. Yes. So where J is the motor inertia as well as the external load inertia. Both is to be considered into account. And similarly, friction is also considered the motor friction as well as the load friction. Yes. And TL dash is the load torque referred to the motor shaft. TL dash is the load torque referred to the motor shaft. Yes. So considering B omega as also a part of the load torque, therefore the above equation can be represented as TD is equal to J d omega by dt plus TL, where TL is equal to B omega plus TL dash. So that is the reason B omega is also a part of the load torque. Yes, this is the equation. Yes. So this dynamic torque, the dynamic control of a DC drive. Yes, the dynamic torque J d omega by dt is equal to TD minus TL. Yes. So TD is the motor torque and TL is the load torque. Here J d omega by dt is the dynamic torque. The dynamic torque can be expressed the difference between the motor torque and the load torque. So let us see what are the different cases when the motor is accelerates, when the motor is maintains constant speed, when the motor is maintained deceleration. So like this is, so acceleration in the sense speed increases. The deceleration means speed decreases and the constant speed. These are the cases. So let us take the case 1. So if the electromagnetic torque developed by the motor is TD is also known as the electromagnetic torque produced by the motor. Yes. So the developed torque is greater than the load torque, is greater than the load torque including friction torque. The motor accelerates, move forwards. So that is, if TD is greater than TL, d omega by dt is greater than 0 and omega increases. This is the case 1. So the TD will dominate the TL. Obviously, the speed increases. And similarly, in case 2, if the electromagnetic torque produced by the motor is less than the load torque, what will happen? The motor is decelerates. Decelerates means the speed will be decreases, are going to be stopped. This is the case when the TD is less than TL. TD is less than TL and d omega by dt is less than 0. Okay. So where omega decreases, omega is decreases. And similarly, case 3, where this situation occurs if TD is negative. Yes. So therefore, which opposing the motion, as in the case of braking, TD and TL are equal, then the motor runs at a constant speed. Yes. So in the case 3, the TD is negative. TD is negative. Also, this will be happen. This I think this situation also occurs if TD is negative, opposing the motion. So I think this statement belongs to the the previous one. This statement belongs to the opposing the motion. This statement belongs to the previous one. Please refer this statement. Yes. So the third case is, in the case of braking, TD and TL are equal. Motor runs at constant speed. Motor runs at constant speed. That is, if TD equal to TL, d omega by dt is equal to 0 and omega constant. So therefore, the drive maintains the constant speed. Yes. Therefore, TL comprises load torque as well as friction torque. So load torques acquiring in mechanical systems may be passive or active. Yes. So therefore, plus or minus TD plus or minus TL, which is equal to J d omega by dt. This is the final ultimate equation. Either TD is plus or minus, TL is plus or minus. So the dynamic torque J d omega by dt is equal to plus or minus TD or plus or minus TL. Yes. It is. So the analysis of dynamics in the electric drive system has completed. Yes. So based upon this dynamic torque, the drive has to be accelerated or deaccelerated. Yes. So it is. We will stop this topic and we will continue in the next topic.